Yes, student. Now I am taking here elastic collision in two dimensions, or it is also called as oblique elastic collision. Obliques means bodies collide elastically, and after collision, the body go in different direction as shown in figure. Here in figure, body of mass m1 moving along x-axis collide with mass m2 which is at rest, and place suppose at origin. You can assume like that. After collision, mass m1 go in this direction, making angle theta 1 with x-axis. Mass m2 goes making angle theta 2 in this direction, and the velocity after collision are v1 and v2. v1 and v2. I think there is no need to write here. Simply you understand this mass m1 moving with velocity u1, suppose in x direction, collides another body of mass m2 which is at rest at origin. You can assume where the body was placed, that was taken as origin. And after collision, mass m1 moves with velocity v1 making theta 1 with initial direction, while mass m2 moving with velocity v2 making angle theta 2 with initial direction. And this collision is supposed to be perfectly elastic. If it is perfectly elastic, if collision is perfectly elastic, then momentum is conserved. Momentum and kinetic energy both are conserved. What is the meaning of conserved? Means momentum before collision is equal to momentum after collision in perfectly elastic collision. So here now applying law of momentum along x-axis. Here the momentum after collision m1 v1, m2 v2 have been resolved along x-axis and y-axis. The component of momentum m1 v1 has magnitude m1 v1 cos theta 1 along x-axis and m1 v1 sin theta 1 along y-axis. And component of momentum m2 v2. This momentum is m2 v2 this side. So its component along x-axis m2 v2 cos theta 2 and along y-axis m2 v2 sin theta 2. So applying law of conservation of momentum along x-axis, we get final momentum क्या है along x-axis m1 v1 cos theta 1 plus m2 v2 cos theta 2 and initial only m1 u1 along y-axis momentum before collision, which is at rest, which momentum 0. It has momentum only m1 u1. M1 u1 the momentum of this body. Remember, momentum is vector quantity. By the way, here these are in same direction, so we have added. This is equation 1. Now applying law of conservation of momentum along y-axis, along y-axis. If this side positive, this is negative. So here m1 b1 sin theta 1 after collision momentum, this is negative, minus m2 b2 sin theta 2 is equal to 0, because initially before collision there was no motion along y-axis, so no momentum along y-axis. This is equation 2. This is equation 2. Now remaining conservation is left of kinetic energy. Kinetic energy is scalar quantity. So applying law of conservation of kinetic energy, not energy. Remember, it is kinetic energy here remains conserved. Total energy to always conserved, because while we say kinetic energy lost in elastic collision, so where that energy goes, that is going to heat, sound and light. You have seen when collision take place between two stones, the stone gets heated and produce light also and sound. So that does not go waste. So here we are talking about conservation of kinetic energy. So what we get? Half m1 b1 square plus half m2 b2 square equal to half m1 u1 square. So we get here three equations. After collision here we get four quantities: v1, v2, theta 1, theta 2. If all four quantities after collision are unknown, then we can't solve these three equations, because as many unknowns are there, the same number of equations should be there. So to solve these equations, any one of four quantities. Who are those four quantities? v1, v2, theta 1, theta 2. Any one of four quantities should be known practically or elsewhere. Practically. और however, कैसे भी वो collide है भाई, तो this is head on in elastic collision. In our NCERT book there is short example based on this oblique collision, oblique head on elastic collision. There is one example, in short example. Actually I lost my NCERT book from here. Some students unknowingly taken that away from here, but I remember the question is that in snooker, you know, जो snooker होता है तो table is there. One is striker, queen, and so this is at rest. They have equal mass, and collide. Here it goes at this angle and this goes this way. If this angle it is at rest. U1 equal to U, U2 equal to 0. And this angle is 37 degree. So you are asked what is this theta 1 or theta. Suppose I write theta 1, theta 2, here 37 degree. I mean these two collide elastically. You are asked here what is theta 1. So how to solve this problem? Both masses are equal. So let velocity after collision be V1 and V2. I will use here vector form. So from law of conservation of momentum, M1 V1 plus M2 V2 equal to M1 U. But here M1 equal to M2 equal to M. So this equation reduced to V1 plus V2 equal to vector U. Actually in book they have taken V initial, V final, so student get confused. Now from law of conservation of kinetic energy, applying law of conservation of energy. What can you write? Half M1 मैं लिख दूँ, half M1 V1 स्क्वायर, अब तो मैं इनको लेना पड़ेगा, प्लस हाफ M V2 स्क्वायर इक्वल टू हाफ M U स्क्वायर, और it gets we get from here half M cancel, तो V1 स्क्वायर प्लस V2 स्क्वायर इक्वल टू U स्क्वायर. Let this angle between be theta. The angle in direction of V1, V2 be theta. How to find here? We have learnt scalar product. Taking scalar product of both sides of equation 1. Taking scalar product on both sides of equation 1, V1 plus V2 dot V1 plus V2 equal to U dot U. तो क्या मिलेगा आपको यहाँ पर? A dot A square. Do you remember dot product? A dot B mathematically equal to modulus A modulus B cos theta. So V1 dot V1 तो B square and hence A dot A. Dear student equal to modulus A square. इसको ऐसे लिखते हैं A square. तो we get here V dot V1 dot V1 V1 square plus V1 dot V2 plus V2 dot V1 plus V2 square equal to U square. A dot B equal to B dot A. ना भाई From equation 2, v1 square plus v2 square equal to u square. यानी कि v1 square plus v2 square plus 2 v1 dot v2 equal to u square. If it is u square here, using equation 1 we get 2v1 dot v2 equal to 0, and hence v1 dot v2 equal to 0, or v1 v2 cos theta 0. So from here cos theta 0, theta 90. If theta 90, then what is theta 1? So theta 1 is equal to 90 minus theta 2, यानी कि 90 minus 37. कितना बचा? 3 और 8, 5, 53 degree. So this is an application of oblique elastic collision. I have seen in my teaching career that teacher avoid this question. By doing question, you know what you get, what you have learned, what you have studied, what you want to learn, you get confirmed कि yes, this happens. तो यहाँ मास m1 m2 बराबर इक्वल थे and m2 was at rest. I hope you will enjoy it, this question. Please see NCERT book. Necessarily you must read NCERT. I have large experience, very long experience of teaching physics, and still I read NCERT book sometime, because I have not read that totally, or if some topic has been read after a long time, something escapes from the brain. So to keep the thing intact in brain, keep on revising the facts. Now in the next video we'll meet with head-on elastic collision.